All right, we're going to do an example. So go down to page 11, number 1. So we're first, have your green sheet out because we're going to be referencing the green sheet. We're first going to figure out what direction this parabola opens. So we looked at the a value, and technically it's 1, and it's positive, which means that our parabola is going to be opening up. So that's something good to keep track of. Our x-intercepts we get from solving this equation when we set it equal to 0. So I'm going to set it equal to 0. I'm going to factor. And then I'm going to use the zero product property to set each of those factors equal to 0 and solve. So my two solutions are x equals -6 and x equals -2. So that means those are my two x-intercepts, and we write them as ordered pairs. So -6, 0, and -2, 0. Alrighty. My y-intercept, remember, the long way, if it's not in standard form, would be to plug 0 in for all the x's and solve. The shortcut is, if it's in standard form, like it is, you can just look at the c value, or the constant. So our y-intercept is 12. So we write it as a ordered pair, 0, 12. The axis of symmetry, from our green sheet, it says is x equals -b over 2a. Our b value is 8, so -8 over 2 times a is technically 1. So then when we solve, -8 over 2 is -4. So our axis of symmetry is at x equals -4. I should be graphing these as we go through, so I'll do that now. I'll graph what we have so far. -6, 0, 2, 3, 4, 5, 6. -2, 0. And our y-intercept is at 0, 12. So that goes off the page, and that's okay. We'll just make our best shot here. And our axis of symmetry is, so I'm just going to use the highlighter here. Our axis of symmetry is at x equals -4, 1, 2, 3, 4. So it's a line that goes right down here. Okay, so far so good. Our vertex is the x value. The x value is the axis of symmetry, and then we plug that in to here, right, for x. So -4 squared plus 8 times -4 plus 12, and you just pull your calculator out and do that. So you're going to get 16 minus 32 plus 12. So I believe we get, if I'm not mistaken, -4. Okay, so our vertex is at -4, -4. And so I'll plot that. 1, 2, 3, 4, 1, 2, 3, 4. Okay. So remember, to finish this out, we need 5 points. Right now we only have 4. Well, our one option, I'll make this a little bit longer, is to reflect our y-intercept over here. It's going to be a little hard because this is not, our y-intercept is not falling on the graph, but we can try our best. So it's going over 1, 2, 3, 4. So we're going to go over 1, 2, 3, 4, and we're going to make sure it kind of matches up there. So that right there is our curve for our parabola. Now, it's not the way I would recommend doing it because, like I said, it does kind of fall off. I would, if I were you, maybe, so we know exactly where our curve's going to be, I would just pick another point, probably somewhere like right here, so we can have our point here. So I would pick an x value that's 1, 2, 3, -3. I would plug that in, and I would get, so if I plug in -3 squared plus 8 times -3 plus 12, I would get 9 minus 24 plus 12, so I would get -3. That works out. So that would actually be there. So we did a pretty good job with our curve. And if we wanted another point, we could just reflect it over and put another point there. So that's our parabola. It wants to know if if our vertex is a maximum or a minimum. Well, our vertex, what it's pretty much asking is our vertex a highest point or our lowest point? Well, in this case, our vertex is our lowest point, so it's a minimum. And then we talked about how the domain for all parabolas is always going to be negative infinity to infinity. And the range is going to be, let's see, our lowest y value is 1, 2, 3, 4, negative 4. So it starts at negative 4 and it goes all the way up to infinity. So that right there is our answer. Okay, so we've graphed it, discovered our domain and range. Perfect. I would like you to try number 2. I put my answer here with work. I'm going to talk you through it. Let me give you one hint. You need to first put this in standard form. Standard form means that the x squared comes first, then the x, and then if you have a constant, put the constant here. So once we put it in standard form, you should discover, okay, our a value is negative, so it's going to open down. When you solve, and like I said, I'm going to talk through this fast, so you're going to have to pause this if you need to write any notes or whatever. When you solve, you're going to pull out a GCF of negative 2x, and then use your zero product property, set both of those factors equal to 0, and then solve. You're going to get your two x-intercepts. Your y-intercept is your c value, if it's in standard form. Well, is there a c value? Technically 0. So our y-intercept's at 0, 0. Our axis of symmetry, negative b over 2a. So when you calculate that, you get x equals 1. So as you can see, I put an axis of symmetry right here. And our vertex is always going to be the same here. So x is 1, and then you plug 1 in, and you get 2. So I graphed that. Now, when I graphed that, I only had these 3 points. So I needed another point. So I plugged in. I was like, okay, I have value at 0, 1, and 2. How about at 3? I need something here at 3, so I know how far down to go. So I plugged in 3. I got negative 6. So I plotted that here. And now, could I have plugged in negative 1? Sure. Right? I would have got negative 6. Or, easier way to do it is just, if I already have this point right here, I could just reflect it over the axis of symmetry. That's the whole point of it. And plot that there. Okay? Sweet. So, there's that. That's the answer for that. Your domain is negative infinity to infinity. Your range is negative infinity to 2. I would like you to skip, and on your own. So, first of all, I'd like you to take a screenshot or a picture of these 2 problems. I'd like you to submit that into the assignment page. And then I would like you to submit this. This is the answers. Now, there should be a lot more work for this. So I'd like you to do the work. Don't look at these answers till you're done. Check your work. Make sure you knew how to do it. And submit a screenshot or a picture of this problem. So this is on page 13, number 3. The one hint I'm going to give you is that you need to first factor out the GCF of negative 1. All right, so again, these are the answers. When you submit your screenshot, there should be a lot more work of how you solved for the x-intercept and how you got the axis of symmetry, things like that. So you're going to solve that, submit those 2 screenshots or pictures, and that's pretty much it. Have a great weekend. Get started on your homework right now. Do not waste your class time. You don't want to do it over the weekend. So get started on your homework right now. Thanks, guys.